Welcome to the Code with Jason meetup. I'm going to share my screen. Today we're going to be working on some testing and OOP stuff like we have for the last few sessions. And Sanjit, I know that you're familiar with this expression parser program that we've been working on. Puneeth, have you seen this expression parser program?
I think no, Jason.
Okay.
Yeah.
I will briefly get you up to speed on this. So here's just a quick overview of the program. And I'm taking this from my new book that I'm working on called Professional Rails Testing.
Mm-hmm.
Give it a moment to compile here. There we go. Okay. So with this expression parser, the idea is that we take a mathematical expression like 2x plus 5, for example, and we parse it into a tree structure. So 2x plus 5 is made up of two sub-expressions, 2x and 5. And so um, that becomes a structure with plus as the root node, and then 5 as one of the children, and times as another one of the children, because 2x is a sub-expression, 2 times x. And then that 2 times x sub-expression becomes a tree with times at the root, and 2 is one of the children, and x is one of the children. And the reason I'm doing this program is because I want to demonstrate some object-oriented programming style. I'm using TDD to build this, but the main focus for this is not TDD, but rather the object-oriented style. So here's what we have so far for the tests. And I think one of the desirable qualities of tests is that you can look at them and gain an understanding of what the system does. So hopefully I'm achieving that in this case. But we have some examples here. One is that when the expression is just a constant, for example, 5, then the roots value is 5, and the left and right child are nil because this is like it doesn't have any
It is only.
children.
Yeah.
Yeah.
So we are building only those nodes and not solving it, correct?
I'm sorry, say it again.
We are building those nodes in like a linked list, correct? Something like that.
Yeah. Yeah, like, a
Okay.
lot like that.
Hmm.
Um, okay, so here's another example. 2 times x. We expect the root to be times, the left child to be 2, and the right child to be x. And we just have a number of examples like that. So this is 2 times x with the explicit times operator. And here's just 2x. It's obviously equivalent to 2 times x, but the multiplication operator is implicit rather than explicit. But we still expect the same thing, root of times, left child of 2, right child of x. Here it is just with a variable other than x to force our program to be a little more versatile. Here is division, same principles, just x divided by 3 instead of whatever it was with times. So root of divides, then x and 3 is the children. Here we do addition. And here's a little bit of a different case. Here's a nested expression. So we are expecting a root of plus and then a left child with a root of time. So this is exactly the same scenario as this.
Yes, Jason.
Yeah. And I am sharing my screen right now, right? Yeah, I am. Okay. I often forget. Okay. And so I'm going to run these tests now. Yeah, and we have a failing test here. So this part of the program is not fully working yet. Looks like we have just one failing test. We're expecting the left child to be a token, but it's an expression. Okay. So the question that might arise for you, at least, Puneeth, is what's a token and what's an expression? What are those two things all about?
Yes, expression, I think it is that 2x plus 5 we are giving. Maybe, I'm not sure.
Yeah, no, you're right.
Yeah.
But then I also wanted a concept for like, for example, what is plus by itself? Even though
Hmm.
5 by itself is an expression and 2x is an expression, plus is not an expression. So what do you call that? I
Oh, correct.
decided with the help
Yeah.
of ChatGPT, I decided we could call that a token.
Okay.
Oh, okay. Not operator then. Okay, anyway.
I mean, it's both.
Okay, yeah. We're going to, for the purpose of this, we call it token. Yeah.
Yeah. So then, 2x plus and 5, those are all tokens. But as things have progressed, the concept of token has gotten more and more empty as I've refactored things. And I've kind of realized that maybe it's not such a useful concept. I'm not sure. And then pretty much all the code has ended up in this expression object. So let's see. I think the task before us today is to parse this nested expression here. Um, and you know what I'm actually going to do? Let's see. Okay, if I look at my git diff, the only thing I've added is this left child with a type of token. I'm actually just going to blow that away. And now if I run the tests, I expect that they'll all pass. Okay, yeah. Okay, they do all pass. And so I think rather than adding more test cases right now, I think I might do a little bit of refactoring and change the way that that some of the stuff is conceptualized. So right now, let's do something here. Okay, so here's my expression. Um, this is a little bit hard to read, but let's maybe try to take it from the bottom up. Or yeah, okay, so we'll start here. So we can see that this expression has a root of plus. Or more precisely, the expression is a token with a value of plus. Then the expression has a left child and right child. So again, it's 2x plus 5. So 2x plus 5, the right child, is an expression with a root of 5 and a left child and right child that are each nil. And the expression's left child is an expression. It has a root of times. Let's see, left child dot left child. Okay, so remember that this expression's left child is 2x. So it's a sub-expression. The left child's left child is 2, and the left child's right child is x. But I think it's a little bit awkward that the children are sometimes a token and sometimes an expression. And I wonder if it might be better if everything is more consistent. Now, not everything is going to be Well, I was going to say not everything is going to be an expression, but maybe that's not even true. So plus is a token, but this root node that has a plus, this whole thing is an expression.
And the whole thing as a whole is also one expression, isn't it?
Right. Oh, let's see. So what exactly about this am I unhappy with? Okay, what do I want to try to do next that I'm currently unable to do? Okay, so the root is plus. The left child's root is times. The left child's left child is 2. The left child's right child is x. I don't have an assertion for 5 yet. Um, see if that works. I assume it will. Oh, but I didn't do that right. Right child dot value. Okay. I'm going to commit that because that works just fine. Okay. Well, I'm not sure. Maybe this data structure is actually fine. Let's keep adding test cases and see where we run into trouble. Um, okay, so let's do this. What about an expression like this? What about like 2 times x plus 3? Let's see, parentheses. We'll do it like that. Actually, let's make it different. Okay. And let's just make it completely different. Okay. Okay, now what do we expect? What is the root of this going to be? So this is basically shorthand for this. So I guess the root will be times. Okay, expected times and got plus. Okay, so this will be interesting. All right, so how do we make it so our expression parser finds parentheses? Well, I will ask ChatGPT. Okay. So what ChatGPT is suggesting is that we use regex to detect parentheses. And then it's suggesting this terribly named method, process parentheses. I say terribly named because process is a basically meaningless word. Okay, interesting. All right, so let's see if we can get away with something simpler than this. Okay, and where do I want to put it? First, we look for a constant, or rather we ask if the expression is a constant. Then we ask if the length is just 1. Then we go through the operators. All right, let's look for parentheses here. We don't have to use regex. We can just do this. And then I do want to grab that splitting logic. Oh, actually, we don't even need this yet. All we need to worry about is making this test pass. This test only says that the root is times. So we can say root equals token.new, whoops, times. Okay, it still doesn't work. Oh, we don't have a return. Okay. So I'm writing only enough code to make the test pass to avoid coding speculatively. I don't want to risk making the code any more complicated than it needs to be. Okay. So that takes care of that case. So the right child now, sorry, the left child would be 6. So let's let's make that assertion. Okay, and that of course does not work. Now we can bring in our parsing. Okay. So can I do this? Left child should be 6. Okay. I'll do that and see if that works. I'll be surprised if it does. Okay. Yeah, it needs to be a token. Okay. Expected the integer 6, but we get a string of 6. Okay. Well, maybe we can just do this. v.toI. Okay, that passes. And all the tests pass. Now, the left child is 6. It's going to have a right child with a root of plus, because x plus 3. Okay, so the right child's root's value is plus. I, of course, expect this not to work. Yeah, undefined method root for nil class because the right child is nil. Let's do this. Undefined method root for token. Okay, and I'm now remembering why I had the desire to change expression and token to something else. Right now it can't handle recursion. So a token can't have a root, or a token just doesn't have a root. I think in this tree, I want every node to be an instance of the same type of object. And I think everything can be an expression. Okay, so I don't want to deal with making this change and refactoring at the same time. So I'm gonna stash everything I have. Okay, all the tests still pass. And I'm gonna do some refactoring. What if instead of a token, everything is an expression? Let's see, an expression would have a root and children. Yeah, I think that idea works.
So shouldn't be that we process the expression till there are no children left.
Yeah, I would think so.
Yeah.
So everywhere I have token.new, let me do expression.new. And when I do that, things will break horribly. Yeah, I think, yep, infinite loop. Okay, so we got to change something. So before we make that refactoring, let's do something that's a little bit of a smaller step. And let's decouple the initialization of an expression from the parsing of an expression. Let's see. Okay, let's do this. Okay, hang on a second. So here in this parse method, we're calling, in all these tests, we're calling the expression.parse class method. And all that does is it initializes an expression. And when an expression gets initialized, it parses itself. What if we do this in a different way? Expression equals new. Okay. You know what? I think I want the idea of like an expression string. Like I have this concept of an expression that implies like a parsed expression. No, it's really like a node. No, maybe that's not the right idea. It's really a tree. Yeah, each one of these is a tree. All right, well, just to add some clarity, let's rename expression to ExpressionTree. We'll have to rename this class, of course. Okay. Okay, and then everywhere we have expression, we'll change it to expression tree. This change will be a little bit trickier, but we'll do expression becomes expression tree. And then in these cases, we'll change this to a space. Okay. Let's see how that's doing. Okay, expression tree. Yeah. Okay. Okay, expression.new, that's on line 39. Okay. Okay. I'll review the changes. No surprises. Rename expression to expression tree. Okay. Oh. Okay. So now this is called expression tree, and I think that adds a little bit of clarity. Expression tree. All right, yeah, and I wanted to decouple the parsing from the initialization. So let's see. Yeah, and I think I want to do this. So now I think I want to have a concept of an expression and then we can parse it into a tree. So this would become like expression tree equals expression.new 5 dot parse. This changes from a class method to an instance method, and this becomes expression tree.new. Okay. And then I'm going to take this entire initialize method and get it out of expression tree. Okay. So the first thing we're doing here is stripping the value. And then we're asking if the value is a constant. All right, so we can move this constant method to expression. Okay. I'm going to run this test, just this test, and see what happens. Uninitialized constant expression. Okay, not surprising. We will require expression. Wrong number of arguments. Given 0, expected 1, expression line 6. Yeah, we're not supposed to have an argument there. Okay, uninitialized constant expression tree. That makes sense because we're not including it. Okay. Oh yeah, it doesn't know anything about value because that's now an instance method. Whoops. Okay, undefined method right child. Okay, expression parser line 16. Oh, undefined method right child for nil. Okay. Okay, we're making progress. All right, so in this case of 5, it should be true that that's just a constant. And we don't want to just return, we want to return the expression tree. So let's see what happens. Define method value for nil class still. Okay. Let's see if we're making it to here. And by the way, I'm tired of doing like require pry and then deleting it. I'm actually going to do something new. I'm going to create a config file. And here I'm going to do require pry.
So you can turn it on and off in one place. Is that what
Or just
you
always
think?
keep it on.
Oh, keep it on. Okay, okay.
Yeah, like I don't feel like it would be appropriate to have every single file say like require pry.
Yeah.
But if every single file says require config, I feel like that is appropriate. Okay, still getting the same error. But here I can put binding.pry to see if it's getting to there. Okay, and it is. Okay, the value is 5. Okay. Okay, and actually let's see something. Okay. The root is nil. All right, so let's go to here now. See what is expression tree. Expression tree is an expression tree. Okay. Oh, we are setting root and left child, etc. on ourself. We need to set it on the expression tree. But I feel like this is a little bit tedious. I feel like we know too much about expression tree. What if instead we just did this? Um, Wait, what is the left child? Oh yeah, token down here. Okay, let's see how that does. Okay, expression tree doesn't take these arguments yet. Okay, it's still nil, but we're not setting them. So root equals root. Oops. Left child equals left child, right child equals right child. Okay, that passes. And all three of these tests pass. Okay. So we'll just go one by one. Now here we can say expression tree is expression.new 2 times x dot parse. We'll see how this one does. Okay, uninitialized constant operators. So we'll move that from here to here. Okay, split on, it's saying is undefined. So we'll move that from here to here. Okay, wrong number of arguments, expression tree line 6, expression 45. Yeah. All right, child expression value. Don't really understand what this is supposed to be all about, so let's look. Okay. The value here is 2 times x. So I think what we actually want. Okay, hang on. What does okay, split on. We're setting left child and right child to split on. So I think we want to parse each one of these. So we want to do expression dot new child expression value dot parse. There, I think that's what we want to do. Okay, now it's saying undefined method right child. Let's focus on just one of these to make it a little bit easier. Okay, undefined method root. Let's see where that's happening. Okay, so it has a root of times. So it's not going to get here because it's not a constant. It's not going to get here because it's not a length of 1 to begin with. I think it's going to come here. So I think we want to do return expression.new. And we'll do like before. Root is token.new. Oh, and then we have this, okay, we have to handle this a little bit differently, I guess. Okay, let's see how that does. Syntax error. Okay, undefined method root for expression. Yeah, I meant to do expression tree.new. Okay, that passes. Okay, but not all three pass. Right child doesn't pass. Let's see why that is. Right child. It's nil. Okay. Value. All right, the value is 2 times x. So is split on not working? Split on gives us an array. The first element is an expression tree, and it looks correct, but the second element is an expression tree that does not look correct. Okay. And here's, I think, maybe why, is because if the value's length is 1, we're not doing the right thing. We want to do return expression tree dot new with a root of token dot new value. left child of token.new nil, right child of token.new nil. I think that's what we want. So now if we do the split on again, yeah, now we get the second element and it's what it's supposed to be, and that passes. Okay. Now if we run all the ones, whoops, we run all the ones in this context, does it work? It does. Okay. Now let's change this one to be the way it needs to be. Expression.parse, sorry, expression.new.parse. Okay, and these all fail, unsurprisingly. Undefined method right child. Again, let's take these one at a time to make them a little bit easier. Undefined method root. Okay. So this is the implicit multiplication. And that is this final case here. So we'll do the same thing we've done a couple times now. Okay, see what we get now. Passes. All those pass. Okay, let's keep going. Okay, that fails because I did it wrong. It's supposed to be expression.new. Okay. Okay, we'll change this now to expression.new.parse. Okay, that passes without any modifications. I expect we'll see that more and more. Okay, this does not pass just because I did it wrong. Okay, that passes. That passes, and now we have a failure. This is back to failing. Let's see why. Undefined method root for expression. Okay. I have a hunch. Here we're returning expression.new.parse. No, I don't think that would have anything to do with it. Okay, let's check this out. Undefined method root for expression. All right, so this is 2 times x. 2 times x is not a constant. It doesn't have a length of 1. So we're going to get to here. Oh, but we don't get to there. Okay. Do we get to here? No. Do we get to here? No. Do we get to here? No. Oh, I'm not calling dot parse. Okay. Now those all pass, and now everything passes. All right, that was a lot of stuff, and I did it pretty fast. So let's review everything. I'm going to commit this, and then we can review. Refactoring. Okay, so expression tree is now almost empty. And actually, let's see if this method is even needed. Oh, it completely is. Okay. Hang on, that's actually kind of weird though. Line 114. Oh, yeah, okay. Maybe that's not weird. Okay, so this expression tree class is pretty empty now. It's only a data structure. It doesn't know anything about parsing, which I think is good. And then it's this expression class that does all the parsing. And now there's kind of a more tidy division. Before it's like, what is an expression? Because this class was called expression before. It's like, is an expression the string representation of the expression? Is it the tree representation of the expression? We're not saying, we're not specifying which it is. Now we're explicitly saying this is an expression tree. And then an expression, that is the string representation. Okay, and we have these fairly distinct chunks where we're saying like, if it's a constant, we're returning this constant expression tree. If it's just a single character, we're doing this single character tree, whatever exactly that is. Then we go through the operators and try to find each operator. Then if it's none of those, we just assume that it's implicit times. Okay, so now after all this refactoring, we might have better hope of doing what we were trying to do before. I don't even remember what it was now. But also, by the way, the split on method, is that what that should be called? What does it do? Like splitting it on an operator and then finding the sub expressions.
But we need that, right? Without that, how are we going to?
I don't know. I can't think of a better way to express it, so I guess I'll just leave it as it is for now. All right, so let's do get stash pop. Okay. Okay, yeah, we're doing parentheses. Oh, and I misspelled this. Parentheses. Okay, yeah, and here we have the case for parentheses. Got to modify this a little bit. Okay, let's see what we get. Oh, and I'm realizing now that I think I want to do even more refactoring before we come back to this. Let's just see what we get though. Okay, undefined method value. Oh, yeah, and let's fix that too. Okay, undefined method root for token. Now we're back to that original problem. So I think I want to do away with the concept of token and just have everything be an expression tree. So everywhere we have token.new, I want to make it ExpressionTree.new. Okay, so right now I just stashed those changes again, and right now all the tests pass. And I think I want to go one by one and change these to ExpressionTree. So I'm sure that that will fail somehow. Okay, wrong number of arguments. Yeah, so I think this should have a root of that. Okay. Missing keywords left child and right child. I think I'm going to make left child and right child optional. Okay. Undefined method value for 5 integer expression tree line 13. Okay. Oh, okay. I'm not thinking through this clearly, I think. So the expression tree's root is itself an expression tree. I think the root should be just a value. Yeah, the root itself is never a tree. It's only a value. Okay. All right, so we have a failure on line 7. Let's take care of that. Anytime I have a big group of failures, I almost always just pick one of them and focus on that to make things a little easier. All right, so I'm going to take everywhere where my test says root.value, and I'm going to change it to just root. Okay, now we have line 23. Does this passes now? Yeah. Okay, we're expecting times operator and we get a token. All right. Now this is multiplication with explicit operator. So I think we'll be coming here. So instead of token the dot new operator, I just want operator. Okay, and that passes now. Still get a bunch of failures. There's one on line 31. Whoops. Okay, expected X got token. So this is still explicit operator. Okay. So I think that means that when the length is just 1, instead of token.new, we just want to set it to value. Okay, that passes now. All right, now we have a failure on line 40. We're expecting root of times, and this is the implicit operator, which is here. All right, so instead of token.new times, we just want times. That passes. Okay, now everything passes. Are we still using token anywhere? We are. Can I just get rid of this entirely? No. It's line 11. All right, instead of left child.value, let's just do left child. Okay. And instead of right child.value, let's do right child. Okay. Okay, and here, I would think I can get rid of those also. Okay. Okay, now we are completely be rid of token, and it can be deleted. Okay. So now everything is an expression tree. Okay, and I'm going to wrap up in a second here because we're a little after the hour. But again, expression tree is just a data structure now. Token's empty. I'm going to remove that from this list here. There's no such thing as a token anymore. We only have this expression class, and it only deals with parsing. And this expression class is much cleaner and tidier than our original expression class was. And I think that the conceptual framework of this program now has a bit more integrity. And I've said before that a program isn't really made out of code, it's made of ideas. And before our, again, conceptual framework, the ideas that this program was made out of were kind of questionable. It didn't have, again, not as much conceptual integrity. And so now that we have these tidier concepts of expression tree and expression, I think we've increased the amount of conceptual integrity. Now, again, can we do this pop and try to deal with this parentheses case? Okay, uninitialized constant token, not surprising. So we don't want to give it a token, we just want to give it times. And this should be expression.new.parse, I believe. Okay, undefined method value for plus. Okay, this shouldn't be root.value, it should just be expression.root. Okay, and that actually passes. Left child is 6, that passes. Okay, it shouldn't be right child root value, it should be right child.root. Well, would you look at that? It passes. So that was easy after we did 30 minutes of refactoring. But it's so much better to invest that 30 minutes in refactoring and then make this change easy rather than work with the kind of conceptual mess that we had before and try to figure out how to fit this new thing awkwardly into this corrupt conceptual framework. Brings to mind the Kent Beck quote, make the hard change easy, warning, this may be hard, and then make the easy change. Okay, I'm gonna commit this. Okay, I feel like I was gonna do something else, but I don't remember what it was. Okay, I do want to tidy this up real quick. I'll at least put this on separate lines. I'll rename v to value. Okay, everything still passes. Oh, and I don't think I need these anymore. Okay. Oh, no, I totally do need those because they're left child and right child. Okay. Okay, this is just a very small refactoring. I remember what I wanted to say. This refactoring I did just now was a pretty radical refactoring. There's absolutely no way that that level of refactoring would have been possible without automated tests. And this might sound like a radical statement, but I don't think it's possible for a program to have good code without tests because you can never do that kind of refactoring. So I think that's a good place to leave it for today. Puneeth, any questions or comments or anything you want to talk about before we go?
No, Jason. Basically, I think I need to like execute the code at my end to understand it better. Can you share that GitHub repository link if possible?
Yeah, yeah. Oh, here it is. Yeah, so this can be found at github.com/jasonsweat/expression parser.
Sure. Okay, I'll check it out, Jason.
Yeah. Yeah, and maybe some final comments here. I mentioned that one of the things that I wanted to convey in these lessons was some object-oriented programming principles. I think the most important thing is how you use what I call the analytical knife to slice up the domain concepts. And before, I had sliced up the domain into these concepts called expression and token. And I think token was a sound concept, but it didn't really apply. The way I was using it was corrupt. It didn't make complete sense. And then my previous expression class was kind of doing two jobs. It had a split personality disorder. It couldn't decide whether it was the string representation of the expression or the data structure. And now, again, we've tidally split that into two different objects. And so that, I think, is the most important thing in any program, whether it's OOP or anything else. So now we have these tidy abstractions. And notice how it's not expression parser service or anything like that. It's these two objects called ExpressionTree and expression. Okay. Anyway, I will leave it there for now. And Puneeth, thanks for joining me, and I'll see you next time.
Yeah, thank you, Jason.